So just to make a quick overview about the welding process for cylindrical cell manufacturing, okay, we have the disc welding process, anode disc to anode surface, cathode disc to cathode surface. We have the cathode disc to can rivet terminal by ultrasonic welding or laser welding or whatever, okay. The lead to can welding, okay, in this case represent, okay, the laser closing system. In case of anode disc in copper, the anode disc will be welded on the internal side of the can, okay, and then the process will move to mechanical closing. In terms of problems, challenges, and so on, we can say that for the disc welding to the jelly roll, the laser welding is the only one used, okay? This gives a lot of flexibility in terms of welding pattern, reduce a lot the resistance, okay, the electrical resistance, and is very, very reliable, no? And even decrease the operational cost for maintenance and so on. And with the laser system right now, there are many companies that are developing inline process monitoring system that are able to control and get a feedback in terms of quality and have a closed loop now with the units. The welding process between the cathode terminal, okay, attached to the can, and the cathode disc foreseen many different solutions, okay? There is the torsional ultrasonic welding, laser welding, electrical resistance welding. Electrical resistance welding was used and is using a lot in the 1865 21700 batteries, so small cylindrical cell with tab. With the new batteries, some people are using torsional ultrasonic welding, some people are using laser welding, okay? Again, ultrasonic welding can have some problem in terms of working life of the tool, okay? And the quality of the welding spot is not super nice. The laser welding has higher investment in terms of unit cost, no maintenance effort, very difficult, quite impossible to weld from the inner hole diameter of the jelly roll. So from here, the blue arrow, is better to weld from external side, but this requires a different terminal design, okay, with some risk. So yeah, I mean, from process point of view is the best solution, but could affect the design of the cell. Which are the risks, okay? For current collector to jelly roll welding, the main defects are separator burn, sputters, pinhole on the disc, okay? Especially in the beginning, no? And at the end of the welding. In terms of quality criteria, are required 25, 30, 40 newtons in terms of peel strength. For the anode, okay, we have the nickel steel plate disc that works as lead. The laser process, the laser welding process, in order to create the laser beam, okay, the welding beam, could remove the nickel plate in the area close to the welding beam. This can trigger some corrosion problems during the working life of the cell, and this could be a huge problem now for the battery pack. So it's very important to have a very fast laser, very fast process to reduce as much as possible the heat affected zone area, and have a very thin, okay, welding seam, okay. Otherwise, we risk really to damage the nickel plate treatment on the disc surface, and this can create some corrosion problem. Regarding the welding process, okay, between the cathode disk and the terminal, again, another problem could be the separator burn, sputters and holes on the cathode disk, okay, due to, for example, the laser process. In case of ultrasonic welding, a problem could be the sticking, of sonotrode here on the cathode surface, since we are talking about a pure aluminum material, okay? And it's very common in pure aluminum have sticking phenomena, in ultrasonic welding. And when there is sticking phenomena, usually the sonotrode release even aluminum particles that can create a huge problems, during the battery functionality. Another problem of ultrasonic welding tool is the working life of the